One of the truly great things about woodworking and DIY is when you spend your money on tools and they don't quite do everything you want them to do, you can do something about it. There are loads of jigs you can build. Think of them like tools for your tools that can make them more versatile, more accurate, safer. And if you'd like to take a shortcut through all the clutter of ideas out there on the internet, I put together this list of 16 projects that I found over the last 10 years have been most worth it to build in my shop. I'll walk you through how I built each one, and I will have plans available if you want that kind of help. And as a bonus, I'm including my favorite tips on organization so you can make your shop a more efficient place to work. Well, there's a lot to cover, so let's get going on project number 1. This mini router table has an adjustable fence with T-track, dust collection, and tool storage, and it can be disassembled without tools. It can be used like this or used like this with no base thanks to a magical new bench dog I discovered. And the best part is you can do this in one weekend and use any palm router. To start, I'm going to focus on the main show, which is the top. And this whole project can be done with just about a quarter sheet of plywood, although I did make a couple of exceptions on mine. So for the top of this table, I'm going to go in a slightly different direction than usual and try this phenolic-coated Baltic birch plywood. Typically for shop projects, I like to go with a Formica on top for a nice durable finish, but I don't have any scraps of that left and I didn't want to buy an entire 4-foot by 8-foot sheet just to do this one project. This phenolic stuff is not cheap. It's about $40 for a 2-foot by 2-foot piece off of Amazon, but that didn't stop my curiosity. I've never used it before, so I'm going to give it a try. You can certainly use the plywood that you build the rest of this table out of and just put some polyurethane on top of it to give it a nice, durable, and slick finish, and I think you're going to be good to go. This 2-foot piece gives me enough material to make the top and the main body of the fence, which I'll build later. The first thing I'll do to the top is cut some grooves in it, which is going to allow me to slide some T-track in there, which will help make the fence adjustable as well as give me some work holding options. I like to make these grooves by setting the fence and then making a cut on both sides, then tapping the fence away from the blade and repeating that process. Using this method guarantees that the tracks are going to be the same distance from each edge. You could do this faster with a dado stack, but I just find using a regular old ripping blade with a flat grind tooth to work just as well for small dados like this. And it means I can sneak up on that sweet, sweet perfect fit. Ah, so satisfying. This build needs 3 pieces of 24-inch T-track, which can be cut down to a final size of 18 inches using the miter saw. Fun fact of the build, aluminum can be cut with regular woodworking blades. And now you know.
And knowing is half the battle.
Ah, Flint. Parenting those latchkey kids. To attach these tracks to the top, I'm going to mix up some 5-minute epoxy. You could use little 1/2-inch screws here, but you're going to need to pre-drill those holes and then grind off the tips of the screws so that they don't blow through the bottom. But that just seems like more work and less reward. Speaking of rewards, I am not capable of using epoxy without spilling it on the surface of my project. Luckily, a little wipe down with acetone cleans that mistake right up, and you get a bonus contact high. So while I wait for that epoxy to fully cure, I go ahead and get started on the fence for this bad boy. I go and grab those other pieces of phenolic ply I cut earlier, and on the face of the fence, I'm going to add another groove for some more T-track. And on the piece that makes the base, I added some pocket holes on the underside. That'll let me join the 2 fence bars together without having screw holes on the face, and nobody's going to see those pocket holes on the bottom of the fence. Next, I added some little dog-eared supports that are going to go on the back side of the fence to help it stay 90 degrees, and some 2-sided tape's going to hold those in place while I drill a pilot hole and sink a screw inside the dado where the T-track's going to eventually cover it up. I added a second screw to the underside of the fence, and 2 screws should hold this together just fine. But just as I was finishing that, I realized I skipped a step in the process. I forgot to add the opening in the fence where the bit goes. That's not too bad. Just unscrew everything like a big fat undo button and keep on trucking. I marked out the center line on both parts since they'll both have mating holes. Anyways, I used a Forster bit to bore out the holes in both pieces, and then over to the bandsaw where I just cut off the remaining little waste bits to make a little archway. A jigsaw is going to work too, or even a small flush trim saw, because I'm not really removing that much material at all. Then everything gets screwed back together and we can move on. Oh, and this T-track gets epoxied just like before. All right, dust collection. This can go a couple of different ways depending on what you have. So the first option is going to be these cheap plastic angled ports that you can buy online. And those are going to go right on the back and just screw into the fence itself. This is going to be good for any standard shop vac that's got a 2.5-inch port. I have a Festool vac though, and this is too big for what I have. So I had to build my own dust port out of just a few scraps of plywood that I glued together. And then I drilled the appropriate size port hole in it, and I'm just going to permanently affix that to the back of the fence. If this is your speed, then I'll leave a link to this down in the description below. Otherwise, the plans will show you how I made the box. To attach the fence, first I line it up with the T-tracks and then find the center of the track and mark that spot on the fence. Then I can transfer my lines up and over to the back side and mark my hole locations with a center punch and drill those out. T-bolts are the main fastener here, and those slide into the track. Then the fence drops on, star knobs lock everything down, and Bob's your uncle. That looks like a fence. And shifting gears for a minute, I need to make the plate, which is going to attach to the router and allow it to drop into the table. I'm making the plate out of a 1/4-inch sheet of acrylic, and I went with black because I think it's going to look really awesome with the phenolic ply, but you can also get this in clear. And just like the aluminum T-track, it can be cut with your regular woodworking tools, but beware that this stuff can be really chippy even with a sharp blade. So I backed up my cuts with a CROSSCUT sled and a piece of scrap wood on top to sandwich the acrylic on all sides, effectively making like a zero clearance cut all the way around the acrylic. And while I'm at it, I went ahead and cut up some extra blanks so that I can make plates with different diameter bit openings. I like making router plates because they seem like they'd be difficult to do, but they're actually really simple. First, you find the center of the blank by marking it from corner to corner, and then just set the router's stock base plate over the top, line it up with that X mark, and then square it up and mark out the screw hole locations. Every router's hole pattern is going to be different, but this process is going to work no matter what. Then the center hole gets bored out with a Forster bit and creates a crazy mess of wild-looking shavings. It's like my Forster bit has some luscious locks now. And the mounting holes, those are a two-step process. Because the heads of the screws need to sit below the surface of the plate, I need to countersink these about halfway through the acrylic with a wider drill bit. Then I can go back with a narrower bit and finish the through holes. And that's really it. Well, almost. Let me just satisfy all the ASMR folks out there with a nice peel. Ah, no, I muffed the peel. Never muff the peel. Well, I may have botched the ASMR, but I nailed these screw holes. The holes are lined up perfectly, and let's go ahead and test that center hole. Oh, yeah. And now that I have a router plate, I can go ahead and make the hole in the table to fit it. I'm going to carefully mark out where I want the opening to go, and mine's going to be centered from side to side, but just a bit forward of the center of the table. Once I have my markings, I can drill out all four corners with a large drill bit, like 1/2 inch or so, and then I can drop my jigsaw in there and cut a rough opening, staying as close to my lines as possible without getting so close that it causes chip out around the edge of where I want my final cut to be. To finish the job, I just created a template out of scraps of plywood. You can use whatever scraps that you have lying around, and I just glued these together with some quickset trim glue, and I used the router plate blank as my guide. Once that dries, two-sided tape's going to do a good job of holding the template in place around the reference lines. In my router, I'm going to chuck up a 1/4 inch spiral flush trim bit from Bits and Bits, which is going to do the job perfectly. But because the bearing is on the top, I need to flip my table over and route it from the other side. That way the bearing can ride along the template, and the key here is to go slow and steady and let those chips clear, and also make sure that you leave no more than 1/4 inch of waste to trim off. Also, remember, when you're routing the inside edge, make sure that you go clockwise with your router. You really don't want any nasty surprises when that bit takes off in your hands. I'll go ahead and leave a link in the description below if you want to check out that bit because it did an amazing job on this plywood. Oh, and if you had any doubts about how strong my two-sided tape is, I needed a pry bar to get it off. Okay, now I just need to round off the corners of this plate so it fits perfectly into the opening, but wait. So I just made a pretty big goof up, and I'm not sure right now how I'm going to fix it. When I went to cut this out and I made the router template, I used the blank as the guide to make the router template. Well, now this is just going to go right through and not sit on a rabbet that was supposed to go around it. And to make things worse, when I cut this out, I also cut up all the other acrylic, so I could have additional blanks. Thinking ahead, right? Well, now I can't cut a new piece that fits the size hole that I have. So yeah, there's that.
George is getting upset!
But with the help of some good-hearted Instagram followers and a little bit of searching, I discovered Woodcraft sells these little adjustable router plate supports. And luckily for me, there's a Woodcraft store in my town, and I don't have to wait for shipping. So off I went and returned with just the fix I needed. I actually think I might like this solution better than what I was planning on doing because these supports have these little leveling screws that you can use to get the plate just flush with the top. It's not often that you can screw up on a project, but end up with a better solution that you can implement the same day. And the last thing I'm going to do to this top is add a couple of very precisely placed 20mm dog holes, and that's because I want to be able to fasten this to my MFT top using these amazing little power lock dogs. If you don't know about these power lock dogs, just go back and watch my video, 9 Tools I Regret Not Buying Sooner, because I go into a little bit more detail about how they work. Anyways, I need to drill these holes precisely over the location of 2 of these MFT dog holes, and there's at least 2 ways to do that. A couple videos ago, I made a portable workbench, and I put a grid of dog holes on top using the UJK Parf Guide system, which helps you create an exact replica of an MFT top. And I also thought ahead and made this template using the Parf Guide system so that I could drill these precise holes without having to set up that jig again. So I can just line up this template where I want my holes to be placed, fasten it to my workpiece, and then drill those out using a 20mm drill bit. The key here is to drill these holes as straight as possible, and that's why I'm using this little guide from the Parf system. You can also use a portable drill guide or just do it by hand and let the template guide the bit straight. Another way to do this, if you already have an MFT, is that you could just clamp your workpiece to it and go underneath and use your 20mm bit to mark the center of the hole location. Then just drill it out. And the last thing I need to do is just put a tiny little chamfer on these holes to accept the power lock dogs. And UJK makes this little chamfer reamer tool that you can attach to your drill, and this will clean out your dog holes as well as cut the little chamfer on the top. Or you could just use a router with a chamfer bit in it, which works just as well. And now I can just slide these power lock dogs into those holes and through the MFT. And when I turn this little bolt on top, this is going to clamp down. And now I have a perfectly secured connection, and it's completely flush with the top so that the router fence can slide right over it and no clamps are getting in the way. I'm telling you, these power lock dogs are so clutch. And after I drop in the router and set the fence in place, I love this thing even more than I imagined when I designed it. It's the perfect working height for me as a natural extension of the work table, and I have easy access to the router switch. And the dust collection through that little port is great. There's nary a sign of debris under the router. So you could stop right here and you'd have a pretty awesome little router table, but I'm not done. I want more options. While it's nice to hang the router off my MFT table, I realize that some people may not have that option, and sometimes I may want to use this thing in different locations in my shop, so I want to make a base. And as I was designing the base, I had 3 main requirements. It needs to be as lightweight as possible, it needs to disassemble easily, that way when I'm not using it, it can store away, or it's easier to travel with, and it also needs to have a tool caddy so I can keep some bits and my collet wrench close at hand. Once I get the sides cut to final dimensions, I'm going to go ahead and cut out a large chunk to give it kind of a cantilevered look. And to make this whole process easier, I'm actually going to gang the 2 sides together into one piece. That way, whatever I cut out is done to both sides at the same time, making sure that they are exactly matching. I marked out some layout lines where I thought the cuts needed to go, and these are just rough guides in my opinion with no curves or anything special about them. I made the basic straight cuts at my bandsaw, but you could also use a jigsaw for this. I just find a bandsaw to be a little bit more enjoyable for these types of cuts on smaller pieces. I removed most of the waste and stayed just off of my layout lines, and then I could take this over to the belt sander and sand back to those lines that I drew. Then I can round over the outside corners, but those inside corners are going to be a little more difficult and something that I can't really reach with this belt sander. So I'm going to swap over to the spindle sander to really get in those inside corners and then finish off and finesse the entire profile until I arrive at this. To be able to attach this base, I'm going to go ahead and add some cleats to the top edge of the sides. To connect the cleats, I'm going to use dowels. Now, I could definitely use my domino here, but I never really use a doweling jig anymore, so I thought I might give it a little love. But I ain't gonna lie though, kids, after using a domino, I don't like dowels. Well, the dowels are fine, it's just the layout process and the jigs and lack of adjustment options, I'm just not a fan. But I do it because I love you, and with a little glue and clamps, we wait. Oh, one thing I totally should have done while my sides were still ganged together is add the notch on the back side, which is where the back stretcher is going to be housed. That will save you some time, and you won't have to contend with those cleats, but my pain is your gain, I guess. I just sneak right up on that fit, and then I want to add some threaded inserts. Remember I said I wanted this to disassemble easily, and so I decided to make it so that it can be taken apart without the need for tools. Locating the threaded inserts is a fairly easy process with a pilot hole going through the back stretcher and into the side. This will make sure that the back stretcher lines up perfectly with the location of that threaded insert. Then I can go back and enlarge those pilot holes to fit the size of the threaded insert. And sorry for the shoddy camera work here, but apparently the camera decided it wanted to focus on all the things except my inserts. I added these without epoxy, but you can certainly add a dab to the threads if you want to. I just find that they grip really well without it. Ah, there we go. Now you can see them. Quick side note, I went back and made the back stretcher a little longer so that it sits proud on each side by about 1/4 of an inch. I was a little afraid that there wasn't enough material between the bolt hole and the edge of the stretcher, and I didn't want to risk breaking it. For the feet, I cut out 2 strips and added a couple of dowels to each one. Those correspond to holes that I drilled on the bottom of this blank, which is eventually going to be the tool caddy. And they just slip together like this, no glue, just friction. I'm adding the blank now as a spacer to align where the feet should screw into the base. I'm using a clamp here just to bring those sides in contact with the side of the blanks. Not too tight because I want to be able to pop that caddy out in the future. Then I can draw some reference lines and countersink some pilot holes using my favorite bit from Amana Tools. It drills the pilot hole and countersinks in one shot. Okay, you could stop right there with the feet, but I wanted to take it one step further because that's what I do. I thought I should add some more of those dog holes so that I could use my power lock dogs on the base as well. I used the same template as before and added a pair of holes to each foot on the outside, not on the inside. You see, I made the foot so that it sticks out wide on the sides of the base. That way, if you want to add these holes, you can, or if you just want to use clamps, you can do that too. See, options are the best. Now I need to fasten the base to the top, and I'm using threaded inserts again for that. I added some holes to the cleats, and then I used the brad point on the end of the drill bit to locate the position of the center of the hole on the bottom of the table. But that poor planning monster reared his ugly head one more time because, well, I think he missed me. So I'm telling you, the fun on this project is apparently not over because I went to drill the holes where I was going to add the threaded inserts, and it's running directly into where the T-track is. So that's obviously not going to work. So my solve for that's going to be I'm going to cut a couple strips of plywood 7/8 of an inch wide and scab those onto the cleats that are on the top side of the base and then re-drill holes there. And that will effectively move the position of the threaded inserts this direction so that they clear the T-track space. With my holes relocated to their new, safer homes, I added my inserts. Again, I used no epoxy, and again, you can do what you want. I did find these smaller thumb screws online, and I think I like them better for this purpose because they're really low profile and they're not going to get in the way, and they're cheaper. And you can see here how the added height of the base makes it better to use on my outfeed table because it's much lower than my MFT workstation. The power lock dogs still work beautifully, and my router table's not going to move anywhere when I'm making cuts. So with everything reinstalled, there's just one more little detail to add, and that is a proper tool caddy. To create the tray, I just made another template like I did when I cut the hole in the top, and I routed out the pocket using a bowl bit with a bearing on it, also from Bits and Bits. I want to cut about 1/4 of an inch into the wood, so I took this in 2 passes to safely cut this out by hand. And a Forster bit makes quick work of some holes that are going to run along the front edge for router bit storage, and I make these holes just large enough so that I could use some of these Rockler router bit storage inserts. They just pop, pop, pop in there nice and tidy. And yeah, I made my tool caddy out of a scrap of walnut because I'm bougie like that, but you can use plywood or anything else you want. And before I call it a day, I'm going to go ahead and disassemble everything just so that I can soften up those corners and sharp edges. I don't know about you, but I love being able to get out in the shop on a weekend and just knock out a quick shop project. Not only is it a fun change of pace, but in the end, you get a cool jig that makes a positive impact on your shop. I hope you found this build inspiring. Thanks for watching. Alright, so the first method I'm going to try is using the table saw, and I've never actually done this one before, so I need to make the jig first. To start, I made a runner out of hardwood to ride in the miter slot. Then I'll cover that with 2-sided tape, which is going to help me position the runner on the jig. I also need to go ahead and add some washers into the runner so that it sits proud of the surface of the saw, otherwise the tape is not going to be able to do its job. Then I can just drop a scrap of plywood onto the tape and press. Now I can just lift the jig off the saw and the runner comes with it. After that, I can drill some pilot holes into the jig and secure the runner in place. Now once that's done, I can run the jig across the blade to remove the excess and we are ready to go. To cut a circle on this jig, I need to set the distance from the blade to the pivot point. Basically, however big you want your circle to be, just divide that by 2 and that's where you make your mark. I drilled a 1/4 inch hole into the jig and inserted a 1/4 inch dowel. Now I need to find the center of my workpiece, and to do that, I mark it with a straight edge from corner to corner, and where those lines meet is my center. I then drill a 1/4 inch hole about halfway through the bottom side of my workpiece, and this method does assume that the bottom of the workpiece will never be visible, something like the bottom of a table. Now I can just drop my workpiece onto the pin and check that it's nice and spinny. Okay, so the way this method works is I need to cut corners. No, like literally cut the corners one by one. After I cut the big corners off, I rotate the piece and move on to each new corner, cutting them off as they get smaller and smaller. It's actually pretty cool as I do this to see the circle begin to take form, and at this point I can finish it off by positioning the workpiece right at the cutting edge of the blade and spin it until it's perfectly round. So this method actually turned out to work surprisingly well. Now my initial thoughts were that this method was going to be tedious and a little messy and not leave a very clean edge. And while it was slow to cut all those corners one by one, and there is a limitation to the size of the circle that you can make on a jig like this, the edge is what's really impressing me. It's very clean, very smooth, and even though I have an 80-tooth CROSSCUT blade on my table saw, this is much better than what I was expecting out of this method, and this might actually give my favorite way of cutting circles a run for its money. Okay, moving right along, the next method for cutting circles is actually my favorite, and that's done with a jig at the bandsaw. Now this is my jig, and just like the table saw jig, it has a runner and has holes at different distances from the blade and also a pivot pin. And the jig goes right to the edge of the blade just like it does at the table saw. Once again, I make a hole in the center of my workpiece and drop it onto the pivot pin. Now here's where this method differs from the table saw. With one smooth, nearly effortless motion, I can spin the workpiece and create my circle. Of all the methods for creating circles that I've found, I don't think any of them beat the bandsaw for speed and effort. The one downside to this method is that the bandsaw blade does leave a pretty rough edge. It's nothing that a little sanding can't clean up, but this edge is definitely not nearly as smooth as what just came off the table saw. One question that you may have is, what do I do if I can't put a hole in my workpiece? Well, here's the solve for that. I created a circle with a pivot hole already all the way through it. I then used 2-sided tape to stick that circle to my workpiece. I can then just drop that right on the pivot pin of my jig, and I can go ahead and make the cut without needing a hole in my workpiece. The 2-sided tape holds really well, and this method requires so little effort that I can control the workpiece with just a couple fingers, so I'm not really putting any pressure or torque on that 2-sided tape. This is a great option if you're making cutting boards or other items where you don't want a hole in your workpiece. So the bandsaw method offers several pros. It's by far the fastest method that I found for cutting circles, and it's pretty effortless to turn the workpiece through the saw blade. It's a pretty clean process, and the bandsaw is a relatively safe tool to use in the shop. Now the bandsaw blade does leave a pretty rough edge that will need some sanding to make it smooth, and of course you do have a cut capacity on this type of jig. Mine goes to 26 inches. If you have a bigger bandsaw, you might be able to do bigger circles, but if you're looking for a bigger circle, the next method might be the one that you want. That brings us to method number 3, which is probably the most well-known way to cut circles, and that's using a router and a trammel. To make a trammel, I just cut a strip of 1/4-inch Baltic birch ply at the table saw. I then use my router base plate to mark the position of the router at one end of the ply, and on the other end I make a smaller circle just using a can. Next I draw 2 lines from the edge of the little circle to the edge of the big circle. Now with the basic outline drawn, I can take this over to the bandsaw and cut out this shape, staying just outside of my lines. Now this doesn't have to be perfect, just close, because I'm going to take this back to the sander and sand everything smooth and clean back to my lines. Now once that's done, I can use the base plate again to mark the center hole and the screw placements. I used a Forstner bit to drill out the center and then drilled the screw holes. And also make sure that you countersink these holes so that the screws sit below the surface of the jig and don't interfere with its operation. And last, I drilled a series of 1/4-inch holes down the center of the jig at 1/2-inch intervals. Now I can fasten the trammel to my router and I'm all set. I went ahead and made a trammel for my small router as well. And I made these little grooves so that I could write the circle diameter for each pivot hole. Now I can just drop the trammel onto my pivot pin like so and plunge a 1/4-inch into my workpiece. At this point I can just spin the trammel and the router and make the cut before I plunge deeper and continue cutting. At this point I could continue plunging and cut my way all the way through the workpiece, but that can be a bit dangerous if you don't have your work and offcuts properly supported, and it can also leave chip out on the opposite edge of the workpiece. What I like to do is finish the cut with a jigsaw, following the path of the trench that I made and staying away from the workpiece as much as possible. This will leave me with a little bit of waste at the bottom to deal with. But I also have a nice smooth reference edge to act as a template for the rest of the cut. So to do this, I'm going to go ahead and use a flush trim bit on my router. The bearing of the bit will ride along the smooth edge and flush up the waste. The end result is a perfectly smooth round circle. Okay, so here's my take on the router method. The pros of doing it this way is that you can pretty much make any size circle you need, provided that your trammel is big enough. The trammel on my large router can make up to a 4-foot circle. I can't imagine needing to make anything bigger than that, but I could if I wanted to. Another pro is that this method leaves a pretty clean edge that doesn't require much sanding. Now there are a few cons to this method as well, one of them being that you pretty much have to have a hole in your workpiece. A router is a pretty dangerous tool as it is, and I wouldn't trust operating it if the center was being held in place by 2-sided tape, because you don't have nearly as much control over the tool and the workpiece like you do at the table saw or the bandsaw. Now another con is that this method is pretty tedious. Depending on how thick your workpiece is, you're going to be making multiple revolutions, plunging just a little bit at a time and going pretty slow with that router until you get down deep enough that you can finish off the cut with a jigsaw or a bandsaw. And finally, and this may be the biggest con depending on your point of view, is that this method is by far the messiest. I made one heck of a mess cutting out this tabletop, and it may take me just as long to clean this up as it did to actually cut out the circle. So what if you don't have a router or you find routers intimidating to use? Well, do you have a jigsaw? Method number 4 is probably the most cost-effective way to cut out your circles, and to do it, I made another trammel. The only difference between this and the router trammel is that the business end of this one is shaped like a jigsaw base, not round like a router base. And since you can't screw it to the bottom like you can with a router, I need to make a small place for the jigsaw to sit, and I just use some scraps of ply to do that. I just glued these little strips to the trammel, making sure that everything was nice and square and that the jigsaw fit snugly inside. You really don't want to have any play here because you won't get a perfectly round circle if you do. I then went back and fastened them with screws just to make sure that those little pieces never came apart from the trammel in the middle of a cut. Now, one final detail is that I marked reference lines to show where the inside edge of the jigsaw blade lines up with the trammel. You can see here that this trammel has a center hole and also pivot points that line up with that hole. Now, I will say to do this method, it is best if you size your workpiece first to the dimension of your finished circle. That way you can just drop the jigsaw in and begin cutting. But if your workpiece is larger than the final circle will be, you're going to have to drill a pilot hole for the blade to have clearance to begin the cut. And just like that, I've got another circle. So the jigsaw method is a very interesting option. You get the same large cut capacity that you get with the router method, but there are some key differences. A jigsaw is a cheaper and I think less intimidating tool to use, so that makes this method a little more accessible to the beginner woodworker. It's also faster because you're only going around that circle once instead of multiple times like I did with the router, and it was a lot cleaner than using the router as well. Now, the one downside that I found and what you're really going to have to watch out for is what it does to the edge of your circle. I did get a lot of tear out on this method, and that's something that would definitely have to be figured out or corrected if you really cared about how smooth and clean that edge was on your workpiece. But if you can figure that out, I think this is a pretty good method. All right, my final thoughts on which methods to use are, if you've got a really large circle to cut out, I would go ahead and stick with the router method. For cut capacity and cleanness of edge, I still think that is the best bet there. Now, if you want a really clean edge right off the tool and the circle doesn't have to be really huge, I would definitely try that table saw method. I was super impressed with how clean that edge was right off the cut. Now, if you need to make circles on a budget, I would go ahead and try the jigsaw method. There was the little issue of chip out that I think can be solved, and if you can get past that, that is a really nice beginner option. But my best and favorite is still the bandsaw method. I think that when it comes to cutting circles easily and quickly and cleanly and safely, the bandsaw method is still the way to go for me. Now let's move on to making a new drill press table. To create the drill press table, I start by cutting 2 pieces of 3/4 inch ply and laminating them together with glue. I get clamps on wherever I can reach, and in the middle I use screws countersunk from the bottom to apply clamping pressure there, and these are going to just be removed later once the glue is dry. And once that glue is dry, I head over to the joiner to make one edge flat so I can use it as a reference. Then back to the table saw where I put that edge against the fence and cut the opposite side parallel to it. I then use my CROSSCUT sled to trim and square up the other 2 sides. Now is a good time to go ahead and label the front and back edge of this table as reference for what's coming next. I then begin laying out the various features like T-track slots and clearance for the drill press post. I want to know where these are located because I'm going to add room for magnets all along the back edge to catch any stray bits that might wander off the edge of the table. After marking the locations with a center punch, I use a Forstner bit to drill a series of 1/8 inch deep pockets. And the magnets I'm using are going to be held in place with CA glue. Now that all the magnets are in place, I'm going to go ahead and add a layer of black Formica to the top. And to do this, I'm using contact cement. If you've never used Formica before, it's a really tough surface and it's going to take a lot of wear and tear over time, not to mention adding a really sweet look to this table. And if you're wondering, you can buy 4x8 sheets of Formica at your local flooring store or anywhere that sells countertop supplies. Sometimes you can even get lucky and find sheets of this stuff at your big box home store. After pressing the Formica onto the plywood, the bond is more or less permanent. I can then use my trim router to flush up the Formica to the table. How awesome does that look? Okay, next I need to cut some dados in the top and bottom to accept some T-track. Since my T-track is going to be the same distance from both edges of the table, I can make a cut, then flip my workpiece around and make the second cut. Then I just nudge the fence away from the blade and make my next cut. Repeating this process allows me to sneak up on the cut so that the T-track fits perfectly with no slop. I then repeated this whole process over on the bottom side of the table, and you'll see why I'm doing that soon. Next, I'm going to cut a notch out of the back of the table to accommodate the pillar of the drill press. This will allow for a little extra depth if I need to reposition the table to drill a hole in a hard-to-reach place. I started this process by using my jigsaw, but I quickly noticed that the upward cut of the blade was chipping out the formica in a pretty bad way. To finish this process, I went over to the bandsaw, which has a downward cutting motion. This resulted in a much better experience, and I had a lot more control over the finer cuts as well. And I finished this up by sanding the curve smooth back to the reference lines. Next, I trimmed off a small bit of the front corners with my track saw. I like this feature because it removes any sharp corners that you might bump into, and this area of the table really isn't necessary for supporting your workpiece. After that, I need to cut my T-track to length, so I mark my cut lines and trim it all at the miter saw. If you didn't know, it's perfectly fine to cut aluminum with woodworking tools. With a self-centering bit, I drill the pilot holes and screw the track into place. Alright, now for the fun part. I need to create a recess here to install a sacrificial plate. To do that, I cut a circle from a scrap of plywood and attached it with two-sided tape. I'm going to start by hogging out the majority of the material with a Forstner bit. I needed to move over to a hand drill for the last bit because my drill press couldn't reach it. To finish it off, I'm going to use a flush trim bit in the router, which is going to leave a flat bottom and a smooth wall. I then go back to the drill press to make a through hole. This is going to allow me to pop the sacrificial plate out from underneath when it gets all chewed up. For the sacrificial plates, I put a small chamfer on both sides, and this is just going to allow them to easily fall into that recess that I made on the table. It also makes it easier to spin by reducing the friction, and spinning this is going to allow me to use all parts of the sacrificial plate before I throw it away. One final touch is to chamfer all the edges and reinstall the T-track. To install the new table, I just add T-bolts to those tracks that I added on the underside of the table and then align those to the slots on the stock table of the drill press. A couple fender washers and some wing nuts are going to keep everything firmly in place. So for the fence on this table, I went with an aluminum extrusion from a company called Masumi. Now they've got lots of different aluminum profiles that you can purchase, but this one seemed to be perfect for my application. And it's considerably cheaper than if you were to go buy an aluminum fence from a woodworking supplier. This 600mm piece cost me about $12. It's got tracks in it so that you can attach stop blocks to it, and I can also use it in the upright position like this for more support, or lay it on its side and use it as a really low profile fence so that the handles of the drill press don't bump into it. To make the fence work, all I need to do is drill some holes for the T-bolts. I'm adding these holes on the wide face of the fence as well so that I can use this fence in both directions. Then I can add the fence and this thing is ready to rock. And you can see here how those magnets that I put in the back do a great job of holding stray bits and keep them from rolling off the table. I can also use the bottom tracks to store my stop blocks and hold downs. So if you've watched my channel before, you probably know I rely heavily on my track saw, especially when cutting sheet goods. It has very good dust collection and utilizes a track like this one to make perfectly straight cuts. And honestly, I consider this to be a buy as soon as you can kind of tool, but I understand a lot of woodworkers just don't have the budget for it, and so here's a quick and easy way to avoid that purchase. This jig will actually take a circular saw and turn it into a passable track saw and save you hundreds of dollars in the process. The first thing to do is cut a strip of 1/2-inch plywood. How wide you cut this strip could vary, and I'll explain why in a minute, but the length can really be anything you want. I recommend making this jig at least 5 feet long, and that way you have enough runway to cut a full sheet of plywood in half. Okay, once you have that first cut, you're going to make a second cut, and this one is going to be narrower, but it's going to be the exact same length. I find about 3 inches wide is pretty good for this one, but this too could vary based on your saw. And the key when cutting this strip is that one of the two edges needs to be as dead straight as you can possibly get it, so use whatever method is at your disposal to make that happen. A table saw is a great idea for making that cut, or like I'm doing here, I just stuck a straight edge down to my plywood using two-sided tape and made the cut. And now that we have our strips, here's how to build the jig. I'm going to attach the smaller strip to the larger one, but first I need to know how much room I need to leave on this side of the jig. And the measurement I need to know is the distance between the edge of my saw plate and the edge of the saw blade. In my case, that's 5 inches. So I want to make sure this edge is more than 5 inches from this edge. Now I can attach this with whatever. I'm using pin nails at first just to hold it in place, and then I'll go back and countersink some holes and lock it down with screws. And it really doesn't matter if this strip is perfectly straight, just as long as this is the straight edge. Then I need to clamp my jig down to something, and in this case that's going to be my workbench, and I'm going to run my saw across the jig, keeping firm, steady pressure on the plate so that it doesn't lose contact with the straight edge. Now I have a perfect zero clearance edge that's parallel to the straight edge. And a quick tip here is make sure you have the right kind of blade in your saw. When you get a circ saw, it's most likely going to come with a general construction blade, which is just going to leave a dirtier cut and possibly more tear out. You want to get a higher tooth count blade that's meant for cross-cutting or cutting sheet goods, and it's going to do much better. And having this be zero clearance is going to make your cuts very clean because it will back up the cut. Remember that the blade rotates like this when it's cutting, so chip out and blowout is most likely to happen on the top side of your material. Here's what that cut edge looks like using the jig, and here's what it looks like using just the saw with no jig. You want to make sure the motor of the saw has plenty of clearance from the clamping area, so measure the distance between the edge of the saw plate and the end of the motor and make that the width of the guide rail. So in summary, a good way to determine how wide to make this jig is by adding the distance from the edge of the saw plate to the edge of the blade, plus about 1/2 inch of waste material, plus the distance from the edge of the saw plate to the end of the motor, plus 1.5 inches. Okay, so you can stop right here and this jig would be ready to go. But one thing I like about my Tracksaw is that I can attach a rail square to it so I can get nice square cuts. To solve for that, I'm going to cut a small strip of plywood. I would make this at least 12 inches to get a nice long reference surface. I'm going to screw one end of it down to the bottom of my jig, keeping clear of the cutting side. Then using a square, I'm going to reference the cutting edge of the jig to make sure that I'm dead square with that edge, and then screw the other side in place. Now I can make square cuts to the edge of the plywood that I'm cutting. Alright, so this is a pretty good substitute for a Tracksaw, and it only cost me a few bucks and a few minutes to make. The next jig I have for you is more than just a jig, it's more like a jig platform, and that's an auxiliary fence for your table saw. This is probably the #1 way to add the most capability possible to your table saw. Hey, if you don't have a full-size cabinet saw, that's okay. You can adapt these ideas to fit your own table saw. As long as it has a sturdy functioning rip fence, that's all that matters. The core of this jig is made up of 2 identical vertical pieces screwed to a horizontal piece made of 2 strips of ply. The key here is that the horizontal piece needs to be the exact width of your table saw fence. There's also a front and back piece glued into place, and the front piece has a notch cut out, and that's just going to be custom to your saw, just to make room for the locking lever of the fence. If you measure the horizontal piece accurately, once you screw the sides on, you should have a snug piston fit onto the rip fence. And before I assembled it, I added these 4 T-nuts here, which are going to allow me to bolt on the first jig, which is the Mega Fence, a nearly 12-inch high fence made of 2 pieces of ply. I added a layer of Formica to mine just for durability, but that's optional. The Mega Fence has a T-track embedded on one side, a notch cut out on the bottom of the other side, and a special miter track on top, which I'll get to in a minute. First, I want to show you just how sturdy this thing is. I could probably push this whole saw across the shop if I wanted to, and this thing's not going to budge. The most basic use for this fence is to make vertical cuts at the table saw. It's great for cutting things like raised panel doors without the need of a router table or expensive set of bits. I can also use it like this and add some feather boards to the T-track so I can make nice safe cuts, or flip the fence around and use this small notch. The notch gives you the ability to make flush trim cuts. The blade's going to sit right under the notch and flush with the side. Where this is super useful is, let's say that I'm making some cabinet parts and I want to have hardwood edge banding across the front. I can glue the edge banding on, and when the glue dries, I can just place my part against this really tall fence and be fully supported through the cut. And because the blade is flush with this face, any material that passes under the notch is going to be cut clean off, and you end up with a perfectly flush trim. Okay, but what about that top rail? Well, I wanted to have a way to use jigs that need to move across the blade. A good example is this vertical support jig. If you need to make a cut on the end of a tall, narrow piece of wood, this gives you full support and keeps the piece perfectly vertical. This is a great way to make things like tenons for frame and panel doors. The way this works is I created this sliding mechanism out of 2 pieces of scrap wood, and before I glued those together, I embedded T-nuts in them so that I can bolt anything to it. And on the bottom, I added the mating piece of this aluminum rail system. It just slides in and locks into the miter rail, and now I have a secure and easy way to glide across the top of the fence. Another jig I created is this simple spline jig. If you've ever made things like picture frames or anything with a mitered edge, this is a great way to make a cut to insert a decorative spline and give that joint some strength. I even added some tool storage up here on top for some of my most used items to be close at hand. And to keep tools from falling off the fence, I even added some magnets embedded into strips of wood. You may have more or less room up here on top depending on how wide your rip fence is, but just make the best use of the space and keep the most used items right up here. And you can make this entire fence and all the jigs just using your table saw and a drill. And there is one more jig that I made for this, but I saved it for last because it's the next on my must-have list. So if you don't have a joiner yet, but you need to make a clean straight edge on a board, or you need to make a long taper cut, you should make an L fence. All this is 2 strips of plywood put together in the shape of...
That's the letter O.
I couldn't find the right clip, but you get it right. The one I made, I cut slots in it so that I could attach it to my mega fence with T-Track, but you could easily just clamp this right to your table saw's rip fence. The concept of the L fence is pretty much the same as that flush cut notch that I made in my tall mega fence, but with a lot more capacity. You just line it up flush with the edge of the table saw blade and then raise the blade up so that it almost touches the bottom. The next thing you need is some kind of straight edge. You could use a straight edge, or I like to just use a strip of wood, a yardstick, whatever. Mark the starting and ending points of your line and then fasten your straight edge to the workpiece right along that line. I like to use 2-sided tape for this, but you could also use hot glue, screws, brad nails, or CA glue. You want the L fence set high enough that the workpiece you're cutting fits completely underneath it, but the straight edge makes solid contact with the edge of the L fence. Now just make the cut keeping the straight edge in contact with the L fence, and everything on the waist side of the line will be cut flush by the blade. And if you pair it with a planer sled, you can completely eliminate the need for a joiner. If your board has twist or bow, set it on the sled and look for any gaps. If there's any rocking, just shim that up until there's no movement and fasten everything with hot glue so it doesn't slide around. This is the simplest jig in this whole video. Just use any sheet good sized to the width of whatever planer you have and then add a cleat to the front. This will turn your planer into a joiner and allows you to completely flatten one face. Then just pop the board off the jig and run the other side through to make it match. Okay, back to the L fence. This works just the same for taper cuts as well, and the nice thing about an L fence compared to say a tapering jig is that you can cut material up to the full height of your table saw's capacity because there's no sled sitting underneath the workpiece. Did you know you could do pattern routing without a router? If you have an odd-shaped item like this giant ring segment that you need to maybe duplicate a few dozen times, the L fence is a great option for that too. Just stick your template onto the workpiece and easily cut off all the waste, making a perfect duplicate. And did you know this method could also be used to cut curves? The same rules apply here as if you were going to use a flush trim bit on a router. You need to apply your template and then cut off any waste using something like a jigsaw or a bandsaw and get within a 1/16 of an inch of the template. Now you can just run this across the L fence, making sure to keep the template in contact with the fence right at the apex of the blade. And now I have a nice smooth curve, and it probably goes without saying, but this only works on outside curves. If you have a concave curve, that's a different technique and a different video. And even though this isn't the most practical way to cut miters, you can do that too. And you can even offset the L fence and then use it to make rabbiting cuts. You could definitely do this just using your table saw's rib fence, but then you risk the little waste piece of material being trapped between the fence and the blade and throwing it back at you like a spear. Hey everybody, I thought instead of peppering you with links throughout the video, I would just take a quick moment right now to remind you that I do have plans available for the projects in this video if you would like that additional level of help. All you've got to do is scan the QR code right here. It'll take you to the plans, or I'll leave links for all those down in the description below. Also, I do have a quite thriving now over 150 member Patreon community, and over there we do things like Q&A sessions as well as behind the scenes content and discount codes for those project plans. So if you'd like to check that out, I'll also leave that down in the description below. Thank you guys as always for watching my videos and supporting what I do. Now, let's get back to those projects. For the most part, I work right here in my shop where I have all the space to get the job done. But sometimes I have to work on location where they don't have those things, so I need a portable workbench that has the same benefits as an MFT with its grid of 20mm dog holes, but that can fit in the back seat of my truck and carry a lot of the accessories that I'd like to have with me. It needs to be extremely accurate, but also as affordable as possible. So to get started, I need to turn this thing into a bunch of smaller things. And I really like these gator grippers for carrying sheet goods around. It really makes it so much easier to do. This project's going to be super quick, and I think it can be accomplished in a weekend, no problem. Lately, I've been making a lot of involved furniture projects with hardwoods and old barnwood, and it's just so nice that I can take some time to crank out a simple shop project every now and then. I like to start by breaking down my plywood into manageable chunks using a track saw or a circular saw, and then cutting it on this sheet of pink foam insulation. This is by far the most convenient thing I've found for cutting plywood because you can cut it over and over again and it just lasts a really long time before you have to replace it. And once the parts are small enough to safely handle, I can turn this job over to my table saw to cut everything from rough to final dimensions, which includes ripping off all the rough factory edges. You will, however, notice me foiling around with a tape measure a bunch, and that's because this was my first project designed in metric. Because the dog hole layout on top needed to be in millimeters to match an MFT top, I just kind of had to roll with millimeters through the entire project design. Another nice thing about this design is that so many of the parts end up being the same width, so you can make a whole lot of the same size strips at once and not have to move your fence around. Now over to the miter saw to cut all of the smaller parts, which is another tool with imperial measurements on it. So here I go, checking and rechecking my metric measurements in between each cut. Yay, metric! Alright, now that I've got all my parts cut, I'm going to focus on creating that perfect grid of dog holes on the top of the workbench. And this is going to be super critical not only for accurate layout and cutting, but also for work holding. And to get this job done, I'm going to go with the UJK Parf Guide system. Now, I haven't used this system yet, but I am super stoked to try it out to see how accurate and easy it is to use. So the first thing I need to do is locate where my starting dog hole is going to be, and I could just measure that out and punch it with a center punch. Once I have that, the Parf system comes with this story stick, which is just a long steel ruler with a bunch of holes in it every 96 millimeters. The story stick is going to get clamped down to the bench right over that starting position. And then I need to use this special drill guide bushing and drill bit to make a hole in the first and last hole that I want to make in the row. The story stick has 11 holes to match what an MFT top would have, but you don't have to do that many if you don't want to. One thing I like about this system is it's very good at using precise guides and bushings to make sure that you're drilling exactly in the center of each one of these hole locations. Once you have those first two holes drilled, you need to put these pins in there, and that's going to hold the story stick in place so that I can remove the clamps and drill out the rest of the holes. And next I need to dust off the cobwebs in my brain to remember the old 3-4-5 rule from geometry, or in this case the 6-8-10 rule, which is how the Parf system makes a perfect right angle. Placing this second story stick in the 6th and 8th holes is all it takes. And now that I have that side done, I need to repeat that whole process on the opposite side. Okay, now I have this set of parallel holes on each end, and the rest of this is cake. I just need to move my ruler to each new set of holes and then drill out all the rows one at a time. Alright, well that was really the hard part of this whole operation. I've got my entire grid of holes precisely laid out. Now all I have to do is go back and widen those to 20 millimeters. To drill the 20 millimeter holes, I'm going to use the Parf guide and a special Forstner bit. So this Parf guide has these 3 millimeter holes that line up perfectly with the grid that you've just drilled out on your worktop. And that allows you to reuse those pins to set the position of the guide. And the 20 millimeter drill bit that you're using here has a 3 millimeter centering pin on it, and that's going to allow you to hit the holes that you created earlier to make sure that you're drilling precisely in the center of that hole location. But after drilling a few of these holes, I did notice that there was more debris in the bottom of the hole than I expected, and so I flipped it over to investigate. No bueno. Blowout City. I really thought that drilling these out on the foam insulation was going to help prevent this problem, but apparently I was wrong. Like, a lot wrong. So my last second Hail Mary pass here is going to be to throw some frog tape on the remaining holes, and then soldier on drilling out the rest of the holes to see if that helped. And once I had enough of these 20 millimeter holes drilled, I could switch over from the pins to using these locator dogs to secure the guide and then drill out the remaining holes. So this whole process took me about 40 minutes from start to finish, which surprised me. But the question is, did that tape work? Well, No, it did not. So I brought my top over to this workstation so I could give it a real thorough sanding and try to work out as much of that blowout as possible. But honestly, there's only going to be so much lipstick I could put on that pig. It's never going to look really nice on the underside, but that's okay because the top looks absolutely flawless. Every single hole perfectly cleanly cut and exactly the way I would expect it to look. So I'm super happy with the way that turned out. Now on the underside, I'm sure that's my fault. If I'd done some reading and research, I'd probably understand the par system is really designed to work to make these MFT tops out of MDF, just like an actual MFT. And so I grabbed a scrap of MDF, put a bunch of 20mm holes in it using that same bit, and it turned out the way it's supposed to look. So just keep that in mind. If you're building one of these for yourself and you're going to use the plywood the way that I did, you're probably going to deal with some blowout on the underside. If that's a problem for you and you want it to be super clean, I would recommend making the top out of MDF. To assemble this workbench, I'm going to use pocket screws. Dominoes would have created a cleaner look, but I wouldn't have been able to disassemble it if I needed to replace the top down the road. To make the pockets, I'm going to use my Castle pocket hole cutter, which is a step up from a standard pocket hole jig because this machine uses routers to cut the pockets instead of a drill, so the holes are a lot cleaner looking and have no debris inside them. And since these pockets are going to be completely visible to me all the time, I wanted them to look as nice as possible. But whatever jig you have to get the job done is what you should use. And even if you choose to use dominoes, the build plans will still work either way. So the first thing that I'm going to attach are these side aprons, and this is done pretty easily by clamping the aprons to my assembly table. Yes, that's right, I need a bench to build a bench. I made sure to precisely place the pocket holes in the same place on both sides of the bench, that way I could establish a safe zone for my tracksaw to cut without risking hitting any screws. And after the apron's attached, the last thing I need to add to the frame is a set of blocking, which I just made by gluing up 3 small pieces of ply. I'm careful to line them up flush with one another and then just use a brad nail to hold them together until the glue dries. The reason for these is it's how I'm going to create a pocket for the legs of this workbench to go into and also add some additional stiffness to the frame. So after pre-drilling and countersinking 4 holes using this nifty countersink drill bit, I can attach the blocking directly to the frame from the outside. And then 1 screw from the inside just for good measure. So in my design, I moved the 2 end aprons inward, and that just allowed me to add the blocking and also create a little pocket on each end that I could add a drawer to. These drawers are going to be super simple, quick and dirty to make. I'm just going to use pocket screws again to assemble them. The front of the drawer is going to be a little bit wider than the rest, and that's just going to cover up where the blocking is on the end of the workbench. And for the drawer bottoms, this is where I strayed away a bit from my original plan of trying to make this out of 1 sheet of plywood because I really think going with 1/4-inch ply on the bottoms makes a lot more sense. So in the end, I think this is a much better choice, even if it means that I'm not using a single sheet of plywood to make this workbench. And because these drawers are so small, you can't really have drawer slides in there. So what I ended up doing is making these little rub strips out of some hardwood scraps, and that's going to eliminate any slop in the drawer's fit. And then to capture the drawer and keep it from falling out, I used another little scrap of 1/4-inch ply to create these bottom covers that are going to go around the leg holes and screw into place. And one last little feature to make sure that these drawers don't fall out when I'm transporting them, I embedded some magnets into the backside of the drawer fronts and then put corresponding magnets in the blocking on the end of the workbench. And then each drawer gets a little small low-profile drawer pull that's going to get the job done and just not be in my way. And what this bench needs next are some legs. Those are going to be made out of strips of ply laminated together. I went ahead and glued up all the legs at one time just so I could use 1 set of clamps, and this is kind of like making a cutting board out of plywood, and I'm careful to make sure everything is flush and lined up before clamping it down. Once the legs are drying out of the clamps, I just need to give them a quick rough sanding to get rid of any of the schmutz from the glue up before I mill everything to final thickness. And yes, I'm running my plywood through my planer. This plywood is Baltic birch ply, and every one of those plies that you see is birch hardwood. So really, there's no difference between this and a cutting board if you think about it. And I do have spiral cutters on the planer, so the finish is nice and clean right out of the machine with just a very tiny bit of blowout on the end. But that's okay because I made these legs extra long so that I could cut them down to final length at the miter saw. You could use a table saw for this if you don't have a planer or if the plywood that you're using isn't solid wood throughout. I also made sure to sand these legs smooth one more time just to make sure that all the corners are rounded over and everything slides in and out of the workbench nice and easy. To store the legs, I created this little pocket on the underside of the bench, and then to hold all the legs in place, I'm just going to use some snap straps. And then to secure the legs while they're in use, I'm going to slide the leg into the pocket that I created with that blocking. And then from the outside, I'm going to drill a small pilot hole through the apron and into the legs. This will perfectly locate where to drill a larger hole that's going to accommodate a threaded insert. And once that hole's made, I can go ahead and tighten the insert into place nice and snug. And you just need to make sure that it's slightly below the surface of the leg so that it doesn't interfere with the operation of the legs as it goes into the workbench. And then I could just drill out a larger hole on the outside of the apron, slide my leg into place, and then fasten the whole thing together using the star knob. So the reason I went with detachable legs instead of, say, like fold-out legs on hinges is that I think this is going to be a lot more stable and prevent wobbling and racking, and it also is going to give me the option to use the bench on flat surfaces like the back of my truck or on the ground when it's just not practical or necessary to get the legs out. All right, one of the other requirements that I had for this workbench is that it have plenty of room for onboard storage, and here are some of the things that I'd like to be able to include. Having these things immediately handy is going to help me get right to work with the tools I use the most. I did a little Googling around and I found these foam blocks that are made for storing test tubes securely, and they just happen to fit 20mm bench dogs. And this foam cuts like a dream on my bandsaw, so getting the perfect fit is going to be easy. And with the perfect fit, these are going to be nice and secure in this drawer, and I can't believe that I lucked out and found these things. And so that got me thinking about the best way to utilize the space in these drawers and make sure that my tools aren't rattling around, and that's when I thought about using lightweight Kaizen foam. This foam can be cut to fit specific tools. You just need to trace around the tools and then use a utility blade to cut that shape out, and the layers can be peeled out one by one, revealing a nice little pocket that's a perfect fit for the item. All right, with the drawers packed out nice and neat, I also wanted to make good use of the space under the bench. I purposely made the space between the two apron ends wide enough to fit a 1080mm Festool guide rail perfectly. And to attach it, I'm going to use the fast cap track racks, which is something that I keep on my garage door for all my other tracks, and I thought this would be a perfect use for those. And that leaves me just enough space to add my bench dog fence system. I can simply put the fence dogs into the dog hole grids on the bottom like this, and then for a little extra security, I install a couple more of those snap straps. And to finish this whole thing off, I'm just going to add a nice comfortable handle on the side for transport. Okay, the last thing I need to do is test this thing for accuracy. Using my bench dog's fence and a couple of dogs to reference the track off of, I'm going to make a cross cut across this plywood panel. Now to check the edge for square. That looks pretty darn good to me. Man, that looks tight. And now I have a portable workbench that both cuts accurately and cost me a little over a sheet of plywood to build, and I think I'm going to be so grateful to have this thing next time I'm working outside the shop.
So what do you do if you have to flatten something so big that you can't use your planer, your drum sander, or your CNC? What if you don't have a planer, a drum sander, or a CNC? Well, stick with me and I'll show you how I did it using half a sheet of plywood and my router. My solution to flattening this butcher block was to build a router flattening sled, or sometimes it's called a slab flattening mill. Basically, the router slides back and forth inside the sled, which rides along two rails, giving me movement on the X and Y axes, and I'm using the plunge router to give me the Z axis. And using a 1 1/4 inch surfacing bit in the router, I can complete this operation in about 15 minutes. So this build starts at the table saw, where I cut the parts for the rails of the mill first. The rails consist of a base and an inner and outer rail part. I can get all the parts for both rails out of a 1/4 sheet of 3/4 inch plywood. I'm also using about a 1 foot scrap of plywood to cut the 4 rail guides that will attach to the bottom of the sled lathe. To assemble a rail, I carefully clamp the inner and outer halves of the rails together, making sure to line them up on the bottom edge. The inner half of the rail is shorter and will provide a place for the rail guides to ride on. I decided not to use glue to fasten these together. I was really concerned that the moisture moisture in the glue would cause warping in such thin strips of plywood, and it's important for these rails to remain as straight as possible. So instead I just pre-drilled and countersunk holes along the rail and fastened the two halves together with screws. I then repeated the same thing with the other rail, aligning the two halves, clamping, countersinking, and screwing it together. The next step is to cut a shallow dado in the base of each rail, maybe a 1/16 of an inch or so. The purpose here is to provide a way to keep the rails straight over time. You can use a dado stack for this, but I just use my ripping blade, which has a flat grind tooth on it, to make a smooth bottom in my dados. I just snuck up on the fit until the rails fit inside, which I apparently forgot to film. I then fastened the base to the rails by pre-drilling, countersinking, and fastening with screws. Next, I set up to cut the bottom of the sled. To get the width for the bottom, I actually use my router as the guide. I push the fence up against it until it touches the blade, and then I back it off by about a 32nd of an inch to provide a little bit of room to prevent binding. Now, to create the slot in the bottom of the sled, I first bore two 1.5 inch holes where I want the slot to begin and end. To finish the slot, I set up feather boards near the blade to create both downward and lateral pressure against the workpiece. I then slide the workpiece over the blade and slowly raise it, pulling the workpiece back and forth across the blade until I cut through to the front and back holes. I then lower the blade back down and flip the workpiece over and repeat the process on the other side, making sure to secure the inner waist piece as I complete the cut to prevent it from catching on the blade and causing kickback. Using clamps, I secure the sides to the bottom with screws, making sure to pre-drill and countersink my holes first. I repeat that process with the two ends. No glue here, just screws, making sure to fasten the ends to the bottom as well as to the sides. And the last step is to fasten the guide rails to the bottom of the sled. To start, I use cyanoacrylate or CA glue to bond the first guide to the bottom edge of the sled. I then use a scrap piece of 3/4 inch ply as a spacer and repeat the process with the inner guide, placing it snugly against the spacer. I go ahead and move the spacer flush with the top of the guides and then fasten the guides to the sled with screws. Now I had to use a regular drill bit here for the extra depth because my runners were a little too long for my countersink bit. I went ahead and knocked off the inside corners of the guides with a block plane here just to help create less binding and a smoother ride on the rails. Okay, now to set up my mill, I use the sled as a spacer and I fasten one end of the rails to my table saw using clamps. I then slide the sled to the other end of the mill, which ensures my two rails are parallel to one another, and I fasten this end to my outfeed table using screws. Your setup may allow you to use clamps on this end too, but mine doesn't, so screws it is. Next, I liberally lube the bottom of the sled with paste wax. This will allow the router to slide smoothly and not bind, which could be really dangerous while operating the router. I also lube both the inside and the outside of the rails with the wax so the guides run smoothly. Now everything slides nice and easy. Hi, it's future me. Sorry for the interruption, but I needed to warn you that using paste wax was not a good idea on those rails. You see all that gunked up sawdust on the rails? Yeah, that can cause the sled to bind, which is exactly what you were trying to prevent. A much better solution is to use dry lube. It won't attract the sawdust and cause the rails to get all gunky like that. Just spray it on, allow a couple minutes for it to dry, and things are nice and slidey again. Okay, that's all I got. Now get back to work. As I mentioned earlier, I'm using a 1.25 inch bit to surface with, and I'm also installing a collet extension to allow the bit to lower enough to reach the workpiece. I begin the flattening process by setting my workpiece on the table saw under the sled. I then put my router in the sled and begin to look for the lowest spot on the workpiece. For me, that's this corner. Then I go ahead and set my router bit to that depth. I'm holding my workpiece laterally using these 150-pound mag switches. I don't really need to hold it down because the workpiece itself weighs about 40 pounds, so it's not going anywhere. I am, however, shimming the workpiece on one corner to remove any rocking before I begin cutting. This is a pretty simple process, really. I start at the lowest spot on the workpiece and begin passing the router back and forth, moving it about 3/4 of an inch at a time between cuts. You want to take slow, steady passes across the workpiece to avoid the router tipping up, causing the bit to gouge your work. As I make progress across the workpiece, I remove more and more material with each pass as I approach the higher spots and the sawdust begins to pile up. Once I completed the first side, I flipped my work over and repeated the sequence on the other side. Once I'm done, I remove the router and the sled and begin to sweep the sawdust to examine my work. I then use my vacuum to clean up this huge mess. And finally, I use my random orbit sander at 60 grit or so to remove the machine marks, and then I progress up to 220 grit until it looks like this. Smooth and flat.
Pop quiz, what do this miter saw and this miter saw have in common?
Isn't it obvious?
Well, it certainly isn't price, but they do share a couple things in common. Unfortunately, neither of them are very good. If you own a miter saw, you know how versatile this tool can be. It's a real workhorse in the shop. But there are things it does not do well, and that's true even for my Fancy Pants Festool. Problem number one is it's very easy to get tear out on a miter saw, especially back here behind the blade. There are some third-party sellers that make zero clearance inserts that go down here in the base of the saw, but not many good options at all for the back. And so this issue makes the miter saw real good for cutting to rough length, but not for cutting finished parts. You could back up the cut with a scrap of wood, but that's just a one-time fix if you cut through the scrap. The second and more dangerous problem is cutting small parts. Pretty much every miter saw comes with a movable fence, but they don't come that close together, making it really dangerous to cut small parts. With this cut, the blade tends to catch the workpiece and pull it backwards, causing some pretty scary kickback. But there's a very easy way to solve these problems by building a zero clearance fence. Think of this as a secondary fence that sits on top of the saw when you need the added capability. To start building this, I cut a piece of MDF slightly larger than the width of my saw's base that almost covers the base from front to back. And I cut another piece that's the same length for the fence. I did the best I could to center the base on the saw so that it overhangs both sides equally, and I used CA glue to add some strips which hug the sides of the saw. That way the base always registers in the same spot every time I use it and there's no wiggle. I use CA glue again to attach the back fence. Then I tacked the cleats in place with brad nails and screwed the back fence into place for added strength. When you're doing this, make sure to avoid placing screws anywhere near the center where the blade's eventually going to cut through. I put the fence in place, and with my depth stop engaged on the saw, I cut my kerf line. Setting the depth stop is key. You want to avoid cutting all the way through the base, only the back fence. Now I have a zero clearance kerf on the bottom and the back, so I can get nice crisp cuts on my finished parts, and I have full support on the back, so I can use something to hold my small parts and cut them very safely. So you could stop right here and have a pretty simple and effective jig, but there is one other problem that all of my miter saws have had, and I think I can build in a solution for that too. Here on my miter saw station, I have these built-in stop blocks with a measuring tape so that I can make accurate, repeatable cuts every time. The problem is, once I transition from the countertop to the miter saw, I lose all my measurements. If I want to cut anything less than, say, 12 inches, I really have a difficult time getting that measurement. So I built another jig, this time cutting a dado across the back using my table saw and adding a piece of T-track. I also cut a second really shallow dado just below it. And the rest of the jig is really built just the same as before, just a little bit wider. Then I can go ahead and recut my zero clearance kerfs, and if you didn't already know, you can cut aluminum using your miter saw. So I'm taking advantage of that fact to make sure that I have a nice zero clearance kerf on the back. So the awesome thing about this zero clearance kerf is that I'll always know where my blade will be every time, so I can add some adhesive measuring tape and place the zero right on that kerf line. You can get this tape in right to left or left to right, so I can measure from either side of the blade. And now I can use a stop block and get a really accurate measurement when cutting small parts. I even added this little note on here to remind myself, make sure to set the depth stop every time I use it. All right, so with this one simple jig, I solved 3 problems that every miter saw has, but in the process, I did create a problem. Anytime that you block the area behind the saw blade, it's going to greatly reduce the dust collection because you've really restricted where that dust can go, and the dust chute on the saw is blocked by the fence. And this is just one of those times where I need to make a trade-off. I really want those additional capabilities on my miter saw, even if it means I get worse dust collection. Besides the fact this is not a jig I'd be leaving on my saw all the time, just when I need to cut small parts or get a really clean edge on a finished part. Whether you have a job site table saw or a full-size cabinet saw, this is an amazingly capable machine that most woodworkers end up making the heart of their shop. That feeling of ripping your first piece of solid wood is a core woodworking memory. But when it comes to cross-cutting, congratulations! Instead of making a memory, you get to make a decision you didn't want to make. Option number 1 is spending anywhere from $150 to $350 on an aftermarket miter gauge. And option number 2 is to use the most god-awful miter gauge that seems to come with every saw. I mean, how could this saw be so expensive and come with such a piece of junk as this? Making a crosscut sled is one of the basic beginner woodworking projects. But if you thought you were done making decisions, whoa, buckle up. You can add T-tracks, tape measures, work holding and blade guards, handles, and miter blocks. We make them too large and heavy. We complicated things by using both miter slots when only one will do, and then there's the eternal battle of keeping this fence square. What I discovered over the last 10 years is that each new sled that I've made was a slow evolution into its simplest form. And this sled is the most recent step in that evolution. It only uses one miter slot, just like a miter gauge would do. It doesn't have the other half of the sled, which already makes it much smaller and lighter. And if I need to support my workpiece on the other side, I just throw down a scrap of ply on the other side of the table to catch my offcut. And when you build a larger sled like this that uses both miter slots, you're forcing yourself into a situation where you've got a fence that's locked in at 90 degrees. But with a sled that doesn't cross over the blade, I have the opportunity to make a pivoting fence. With this, I can cut any angle I want, not just square cuts. I decided to switch to a piece of aluminum extrusion to make this fence, which is more stable and less heavy than plywood. And I even added a replaceable end cap made of wood so that I can fully back up my cuts. With enough use, every crosscut sled is going to go out of square, and they can be a real headache to recalibrate. Most fences are attached with screws from underneath, and if the fence ever goes out of square, you pretty much have to start over with a new set of screw holes, which you can only do so many times before you just have to scrap the whole sled. So if you start with the realization that all fences on all crosscut sleds will go out of square, why wouldn't you make it as easy as possible on yourself to re-square it? On this sled, I did that by adding a positive stop behind the fence using this little bracket, and there's a little threaded hole in it that I can use a cap screw in, so now I can micro adjust the angle of the fence, then I can lock the fence down, and re-squaring takes just a couple minutes. Go ahead, run your 5-cut test, and then make the micro adjustments by turning the little screw, and repeat this until you're happy with the results. Well, there is one teensy problem, which is I never documented how to build this jig, but it's so easy to do, I went ahead and made another one just so you could see how to make it. And that was a lie. I did it because I wanted one in black. So the construction of this sled is really simple. The first thing I did was cut a 24-inch by 25-inch piece of plywood at the table saw. I want to make this sled even more durable, so I'm adding Formica to the top, and this time I'm using black instead of white. I have this stuff all over my workshop on workbenches, tables, fences, and jigs. The way to apply this is to use contact cement. Put a coat of cement on each surface that you want to stick together, and I like to use a roller for this because it makes a nice even coat. Then let the cement sit for a few minutes until it begins to tack up. Now this stuff is going to bond on contact, so one good tip is to use a couple of spacer sticks. These are just offcuts from the shop that you can use to separate the two pieces until you're ready to bond them. Another tip is to make sure you cut your Formica oversized on all sides. You'll have exactly 0 seconds to position this once these two sides touch, so you want some overhang on all sides to make sure that you don't mess up and have to start over. Once I'm into position, I can begin to remove one spacer at a time and press the Formica into place from one edge to the other. When the last spacer is out, they make this special pressure roller which lets you apply a lot of downward force as you roll the Formica to give it a really strong bond with no air bubbles. Now I need to trim all the excess off around these edges, and the best way to do that is to use a flush trim bit in my trim router. That's going to give me a nice, clean, crisp edge all the way around. Additionally, you could add a little chamfer if you wanted to, just to break that edge and soften it a little bit and make sure that you don't get snags on that edge in the future. To create the pivoting fence, I drilled a 1/4-inch hole in the front left corner. That's going to end up being the pivot point for the fence, but first, it's going to be the pivot point for my router trammel, which I'm going to use to cut an arc into the sled. The key here is to go a little beyond square in both directions just to give yourself some play and some room to calibrate the fence later. Once I got completely through the sled, I flipped it over, and I'm going to do that whole process again, but this time using a wider router bit to create a countersink for the bolt heads to sit in. To assemble the sled, I dropped the miter bar into the right-hand slot on top of a couple of washers, and that way it just sits a little bit proud of the surface. I added some two-sided tape to the top and then set the table saw fence 24 inches from the blade. With the sled pressed firmly against the fence, I then dropped it onto the miter bar with about 1 inch of overhang across the blade. And because of that two-sided tape, now I can flip the sled over and my miter bar is precisely in place, and I can go ahead and fasten it with screws. So now is when I would normally raise the blade and cut off the excess, but my camera battery died, so instead here is the finished zero clearance cut. With a bolt in the pivot side and in the arc side, the fence now pivots to any angle I want and locks firmly in place with 2 star knobs from the top. I can just tap in my little wooden end cap, and then the last thing I need to add is this bracket with a cap head screw. I place the bracket slightly behind where square would be, and then that's going to give me room to adjust forward to hit 90 degrees perfectly. Also, this aluminum extrusion comes with a form of T-track already built in, so adding a stop block's really easy and I don't have to buy additional T-track. Oh, and I also drilled a hole here in the top just to hang my sled on the wall. So this is hands down better than a stock miter gauge, but I also think it's better than an aftermarket miter gauge because I get the added benefit of a zero clearance crosscut sled while being able to cut any angle that I want.
So this is one of those projects that's been on my to-do list for a long time because with a few simple additions, you can turn a shop vac into a portable 2-stage dust collector. Having the ability to empty the cyclone bucket and not have to worry about cleaning out the vacuum is pretty appealing. And so is keeping the filter clean so the fine particles stay out of the air for as long as possible. After looking at the many different designs for these types of carts, I knew I wanted the vertical style instead of the side-by-side cart to minimize the footprint in my shop. So the first thing I had to do was figure out the basic dimensions of the vacuum, and I did this by building a box around the vacuum up to the point where it's most wide. This let me know how big the bottom of the cart needed to be. I also got a rough measurement of the height with a scrap piece of wood and a straight rule. One final key measurement was the diameter of the cyclone bucket. With these measurements, I could design the whole cart and get to cutting. I started out by breaking down a 3/4 sheet of Baltic birch plywood. If you're not familiar with it, it's a very stable, high-ply material that is great for shop projects. From this, I could cut the bottom and side panels of my cart to length and width at the table saw. I then cut all the other various parts that make up the upper platform and stretchers and used my CROSSCUT sled to cut them to length. And there you have it, all the parts needed to make the cart. The final bit of cutting on the project had to do with creating the angles and notches on the side panels. I really wanted the base of the cart to angle upward to where the cyclone bucket would sit. This would give the cart a lighter look and give easier access to the switch on the vacuum. The notches will allow the stretchers to nest into the cart, keeping the overall look clean. The notches are fairly easy to take care of at the bandsaw. I used a magnet as a stop and set my fence to the proper distance and cut the long edges, then moved the fence back to finish the job. 4 notches done. To take care of the long tapered cuts, I used a tracksaw. My panels were too big to allow me to effectively cut them on the table saw, and my bandsaw would have left a rough edge that I didn't want on the front of my cart, so I lined up my tracksaw to my marks and made the cuts. If you don't have a tracksaw, a circular saw and straight edge would work for this job too. I then grabbed the bottom panel and drilled a hole in each corner to accept the casters that will come later. So to start construction, I set my bottom and side panels into parallel clamps. These help keep the pieces aligned as well as act as an extra pair of hands. I used a clamp as a spreader, checking for square along the way until everything was right angles. I then secured the 2 sides to the bottom with screws in pre-drilled holes. From there, I added the upper back stretcher by setting it into the notches and screwing it into place. Same thing with the lower back stretcher, placing it into the notches, pre-drill, and screw into place. On the opposite side, I add a front stretcher, which will act as a lip preventing the vacuum from rolling out of the cart. Now it's onto the top of the cart where the cyclone will sit. I butt the bottom panel up against the upper back stretcher and secure it with 4 screws. I then add a front panel by securing it with 3 screws. And finally, I add the 2 side panels by securing them from the front and back with 2 screws each. Next, I add the casters by inserting them into the 4 holes I drilled in the bottom and securing with lock washers and lock nuts. Turning the cart on its side allowed me to securely fasten each caster using a wrench and pliers. At this point, the cart is almost completely assembled, and so I wanted to pause for a minute to make sure that everything fit. The vacuum fit perfectly with almost no wiggle room, and the bucket slid right into place on the top of the cart. Now I can breathe easy. I wanted a way to secure the cyclone and bucket, so I cut 2 dividers and drilled 3/4-inch holes in each side at the drill press. I then added glue to the sides and bottom and slid them into place on either side of the bucket and secured with screws. Using a hole saw, I added a spot to place the broom attachment for my vacuum when I'm done. I then added the cyclone and bucket and secured them by hooking 2 bungee cords into the holes drilled into the dividers. And then I added my vacuum attachments to the area created by the dividers. One final piece of business was connecting the cyclone to the vacuum. I didn't have any extra dust hoses, so instead I went with PVC pipe. I think it adds a cleaner look with no hoses flopping around. I cut my PVC pipe to length and add the cyclone hose adapter to the vacuum. I used 2 90-degree elbows to help create the connection, and with a rubber pipe connector on both ends, I connect the cyclone to the vacuum. And there you have it. One dust collection cart ready for action. I'm really happy with this design. The footprint of the cart, including the PVC, is less than 2 square feet, which makes it only slightly bigger than the vacuum by itself. I can easily access the on-off switch, and the 3-inch casters allow me to move the dust collection cart wherever I need it in the shop easily.
Whether you're new to woodworking or not, you probably have or at least heard of pocket hole jigs, and that's because they're one of the cheapest and most accessible forms of joinery, and that's especially true now with a bunch of brands offering them in their classic format, which is the one that I prefer. I bought this one from Enjoy Wood, and I did a tool video a while back which includes all the reasons why I prefer this jig, and I'll link to that down in the description if you want to check that out after this video. But even though this is my favorite one, that doesn't mean it's perfect. The first thing that I don't like is this tiny reference surface, and that's true of most of the jigs on the market. This is just fine if you're cutting a hole in the end of a 2x4 or a strip of plywood, but it's more of a challenge when you're cutting larger work pieces like this. So if you want to put your pocket hole down here, you've got all this unsupported area which is going to drop and either lever up out of the clamp or just tip the whole jig. Another issue is that some of these jigs come with a lot of accessories to keep track of. And there's no onboard storage anywhere on this jig, so if you lose something, you've either got to find something else to use or buy a whole new accessory. And once again, jigs come to the rescue, and to solve both these problems, I built this pocket hole workstation. It has a nice wide work area, which helps to support large work panels. And one feature that I really like about these jigs is the base is only a 1/2 inch thick, and that's the nice thing about these metal jigs, is they don't have to be as big and bulky as the plastic Craig jig. And the reason that's important is because it gives me the opportunity to recess the jig into the workstation, which is exactly what I did. The jig itself sits flush inside that recess, as well as this T-track, which I added for using stop blocks. That makes repeatable cuts so fast. I also added these tick marks every 2 inches for spacing out my holes evenly. I didn't bother to add any tape measure to this because I just don't think it's practical. You don't really need to be that precise with your pocket hole placements, but over here, I did add some tool storage. And that's because this area is largely unused, so I figured I would carry some of the tools and accessories on board. I have a space here for the drill bit, stop collar, and hex wrench, and I also recessed a space for the depth gauge that comes with the jig. If I didn't do that, I'm positive I'd lose these things in the back of a drawer somewhere, and to hold them in place, I actually recessed some magnets into the back. But the number one thing I love about this jig is you'll notice these seemingly random holes all around. Well, they're actually not random. These are 20mm dog holes, and they're spaced out in exact 96mm increments to match the grid of holes on my assembly table as well as my MFT workstation. And these are used to fasten the jig securely so that it won't slide around during use. Each of these holes has a little chamfer that I added with this tool. You could use a router for this, but this tool is smaller and it just chucks into your drill, so it's super easy to use. And with that little chamfer there, I could use these special lock dogs that are going to go into the holes in the jig and through the holes in the work table, and then you can clamp them down from above using a hex wrench. And 2 of these is really all that you need to hold this jig in place, but I added holes everywhere, so no matter where I need to use this jig, I've got a place that I can fasten it down. I did add some finger grips up here so I could carry the jig around easily, and what I love about this design is it's pretty low profile, so storing it away is really easy and it doesn't take up much room. So then how did I make this? Well, I actually did it by using my CNC, which was by far the fastest and most accurate way to cut out all of these features, and all I had to do at the end was come back and square up these corners with a chisel. But this is totally doable with a handheld router as well. After all, a CNC is just a router that's being controlled by a computer. So What I'm going to do is offer the vector files and the CNC files, as well as a paper template if you want to make one of these for yourself. That way you can cut it out with your CNC, or you can print out the paper templates and use a handheld router, and all those files will be down in the description below.
Hey guys, welcome back to MWA Woodworks. My name is Matt, and in this video I'm going to be showing you how to make and use a coping sled. Actually, two coping sleds. This one that I built out of scrap plywood, and this other one that I built out of aluminum extrusions, which I purchased and assembled myself. Now here at the table saw, you can create simple frame and panel doors. I've done that many times myself, but there are a couple of disadvantages to using this method. The first one is speed. It's going to take a little while to dial in the fit of that tongue and groove joinery, and it's also going to take multiple passes across the table saw blade in order to complete the cuts. And the second thing is going to be the profile on the inside of the frame. Now when you're using a table saw to do this, that's just going to be a straight flat cut around all four sides. But if you want something decorative on the inside, like a chamfer or a roundover, you're going to have to switch to these rail and style bits for your router table. Now the combination of these two bits will allow you to cut the grooves, the profile, and the joinery for your frame and panel doors. And our coping sled is going to help us cope with these. Now making the groove and the profile cut is easy. You have the long edge of the workpiece against the fence and make the cut nice and safe with some hold downs to keep everything in place. But when it's time to make the coping cuts for the mating pieces, you're cutting the end of the workpiece. This is obviously a much more precarious cut because only a very small part of the workpiece is in contact with the fence. You could use a piece of scrap to back up the cut and give the workpiece something to ride against, but there's nothing to keep it from sliding back as you make the cut and creating an ill-fitting joint. This is what the coping sled was made for. It consists of a base for the workpiece to ride on. There's a stationary fence on the right side that provides a nice sturdy and square edge to ride against. There's a movable fence on the left side to hold the workpiece laterally, and a clamp to keep it held down in place. It should also have sturdy handles for guiding the sled and a reference edge to guide the sled a fixed distance from the fence as the sled moves across the bit. And you can see here in this demo, with the workpiece backed up by a piece of scrap to prevent blowout, I can complete this cut safely and accurately. And that's what gives you a tight fit like this. The cope cut fits perfectly over the profiled edge, leaving you with a clean joint. So for the plywood coping sled, I start with a blank and use a Forstner bit to countersink holes where the T-nuts will go. I need 2 for the guidepost, 2 for the stationary fence, and 2 for the handles. Next, I adjust my drill press table upward so that I can cut through holes for the center of the T-nuts. These holes will allow us to attach everything but the sliding fence. To make the sliding fence, well, slide, I need to first route a groove down the center of the base. It needs to be deep enough for the head of a hex bolt to slide below the surface. Then I switch to a smaller bit to cut all the way through, creating a groove for the sliding fence. Next, I install my T-nuts, and one of my favorite ways to do this is by using a clamp. It makes pressing them into the plywood a breeze. Oh yeah, I ended up adding counter bores to the top so that the handles would reach the T-nuts. Those go in first, nice and sturdy. Then on goes the stationary fence with 2 bolts. Before I tighten them down all the way, I'm going to use a square to align the fence. Next, I slide a hex bolt in the bottom of the groove, and I add the sliding fence. And I'm using a knob to tighten the fence down. Now I add 2 standoffs that are going to act like guideposts. These have a male thread on one end and a female thread on the other. Okay, for the fence guide, I cut a piece of 6-inch polycarbonate plastic in half at the table saw. And I add a locator hole on each end, and then pick the plastic swirly piece off the drill. Okay guys, one thing I recommend on this polycarbonate shield is to go ahead and use a router to add a small chamfer all the way around the edges. I did about a 1/16 of an inch on both sides. This stuff is sharp as crap on the edges. As I found out the hard way, I cut myself more than once as I was fiddling around putting this jig together. So go ahead and save yourself that trouble and add the chamfers. So with the chamfer bit and the router table, I took my own advice and trimmed every edge on this polycarbonate to avoid any more future cuts. And I added the guide to the guideposts, securing them with 2 cap nuts. I left the cap nuts loose at first and tightened the guideposts all the way down.
Then I went back and tightened the cap nuts fully using a hex wrench. And last but not least, I added the clamp and give it a test. Good news, it's clampy. Alright, that's it. Our coping sled is now complete. Now I really like this version of the sled. It's very lightweight but sturdy, and it's relatively cheap because I was able to use scraps of plywood and only purchase the hardware for it. And if any of these fence parts get worn out, it's easy to cut new pieces and replace those. Now what if you don't have the scrap to build this and you don't want to buy an entire sheet of 3/4 inch plywood just to build one small jig? Well, that's where I've got you covered with version 2 of the coping sled. Now this uses all the same hardware, but it uses aluminum extrusions for the fences and the base. And that's going to make this a much more sturdy, stout jig. And it's also going to be more configurable because you can move things around in the grooves of the base. It is going to cost a little bit more money for these aluminum extrusions, but you're not going to be spending as much money here as you would be if you were buying an entire sheet of 3/4 inch plywood to build this jig. I will leave a link in the description below for all of the parts and the aluminum that I'm using to make this. So if you'd like to go this route, you can purchase those yourself. Now let me show you how I built it. Now the only real work that's needed to be done here to these parts is to drill holes in the fences so that we can attach them to the base. I located the position of the holes with a center punch. Aluminum is a soft metal, and you may not know this, but you can cut it with regular woodworking blades and drill bits like I'm doing here. Now you can order these parts with the holes already drilled for you, but in my opinion they charge way too much for that operation, and it takes 5 minutes to do it yourself. Now let the assembly fun begin. This time I need to add the stationary fence first. Now you'll notice that I did add a small bit of 1/2 inch ply to the top of the fence, and I'll explain why later. By the way, this time I'm using sliding T-nuts to go in the grooves of the base and hold everything in place. Now like before, I use a square to get the fence lined up. Then I slide on the movable fence. Then I added the clamp. This is why I added the scrap of wood. Now you're probably saying to yourself, didn't he say I could build this sled without any scrap plywood? Absolutely you can. You can screw this clamp directly into the aluminum fence just using regular steel screws. But I was non-committal at first about where I wanted the placement of that clamp to be, and I thought it would be easier to just add the scrap plywood to screw into so that I could move that around easier and not make a bunch of holes in my aluminum fence. So if you are better at making a decision and sticking to it than I am, by all means, lose the scrap plywood and screw it directly into the fence. And that's also going to save you from having to use this longer bolt as well. The bolt that comes with the clamp will work perfectly fine. Next, I add the handles. Now there's several places you can put the handles, which is why I like this version of the sled. Same thing goes for the standoffs. And I added a regular hex nut to these because the thread was too long and it bottomed out in the groove before it was tight. So that hex nut just acts as a little bit of a spacer. Then I just added the guide and tightened it in the same order as before. Now, my indecision about the clamp came back to bite me here. You can see that the clamp head doesn't reach the workpiece because I added the ply. So I opted to make my own longer clamp head using a T-bolt and another scrap of plywood. I drilled out a pocket that the head of the bolt would fit into. I then mixed up some 5-minute epoxy and added it to the recess and then sank the head of the bolt in there and let it dry in place. Once it was dry, I went ahead and added it to the clamp, and the problem that I created that didn't have to exist to begin with was solved. Now this sled is truly a beast. It's much more stout and feels beefy, and the nice thing about the grooves in the base of the sled is that you can change configurations. And here you can see this sled in action.
Many woodworkers faced with constraints on budget or space opt to skip the full-size router table and instead build one into the wing of their table saw. Unlike a store-bought router table, this option lacks a fence. You could add T-track to the table and buy an aftermarket fence, but I think there's a cheaper and better option because I already have a fully adjustable fence right here. I just need to make it more useful. And this was my crack at designing a router fence. It has a nice tall supportive fence, which is great for making vertical cuts. It has T-track in it, so I can add feather boards or stop blocks. And the bottom half of the fence opens up to allow for dust collection. Back here, I've got trays for holding accessories and a dust port. These knobs are used to open and close the front fences, and these knobs hold this fence to my table saw's auxiliary fence. If you don't know about my ultimate table saw fence and all the things it can do, I have a video all about it, and I'll link to that down in the description below if you want to check that out after this video. But I also have the option to attach this to my table saw's rip fence using these two holes and these universal fence clamps. These are great little all-purpose clamps that work on just about any tool with a fence. These do a great job of holding the router fence in place, and now I have infinite adjustability when I need to make cuts using the router. All right, so before I continue, let's establish a couple of things about 10 years ago, Matt, and how I built this. First of all, this is the Frankenstein's monster of jigs. I used MDF, 2 types of plywood, Formica, walnut, and this thing is way overbuilt. I don't know why I thought I needed this to withstand an F5 tornado. So how about this? I'll show you how today Matt would build this, and I'll keep all the stuff I like and get rid of the stuff that I think is just overkill. It'll be just as capable, but something a little more reproducible if you want to build one of these yourself, okay? All right, let's do this. So to start, I need to just cut some strips out of this piece of MDF at the table saw. This is kind of strange for me because I really never build jigs this way. My rule has always been to cobble together jigs from small scraps laying around from past projects. Hence old Frank the Tank over there. These strips are various widths, but they're all 27 inches long. Now I need to take the bottom and the subfence and go and cut a notch in both, and that's going to allow for dust collection later. Use whatever tool you have available to make this cut. I like using the bandsaw to remove the bulk of the waste and then to clean up the bottom of the notch like this. So this opening is 4 inches, so each one of these sides needs to open a maximum of 2 inches. So what I'll do is create 2 slots spaced evenly apart to allow for that 2 inches of travel. To make the slots, I'm going to use my rip fence as a guide and make a plunge cut. I made starting and stopping marks on the top just to make sure that I stayed in that 2-inch range. If you go over, not a big deal, it just doesn't need to be any more than that. Now I can fasten this piece to the bottom with screws. It's important on this whole project that you countersink all of your screw holes because you don't want the heads of the screws to interfere with the operation of any of the moving parts, and my favorite way to do that is with this bit. This bit is made by Amana and it drills a pilot hole and creates a countersink all in one motion. You could do this with a regular drill bit and a countersink like this, but it's twice the work. So if saving time and being efficient is important to you, I highly recommend checking out one of these bits. Okay, next I need to cut this into blocks at the miter saw, and then miter one corner like this. These are going to be the fence supports, and they get screwed into the bottom of the fence and also to the front. And again, I like to rely on a little dab of super glue and activator to temporarily hold my parts in place, which makes fastening small parts like this a lot easier. These supports are flush with the edge and these are flush with the opening. And on my original design, I had these 2 supports doubled up. I think that's overkill, and this time I just went with one. This strip will be the back, and I need to drill 2 holes which correspond to the T-nut locations on my auxiliary fence, and then 2 more holes on the top if I want to use the universal fence clamps. And then that just gets screwed to the bottom as well as the supports. The other part of this design I want to keep is the Formica front, which I applied using the same method that I showed earlier in the video. And again, I used black because it's all I have left, and I think it looks cooler anyways, don't you? The first thing to do is cut a dado in the fence, and this is going to hold that T-track. I'm not going to install it yet. I'm just checking the fit so I can sneak up on the perfect width that I need. I'm going to cut the fence in half, 3/8 of an inch below the bottom of the dado, and then take the offcut and cut it exactly in half. Each of the 2 sliding wings is going to get 2 countersunk holes. That way the bolts can go through into the slots that we cut in the subfence, and the heads of the bolts can sit below the surface. Now I have all my parts cut. I'm going to add a small chamfer all the way around the face of each piece, and that's going to break all the sharp edges and make everything slide better and just give a place for the dust to go under the fence. Mistake of the project. So as I was chamfering everything, I went to chamfer these inside holes as well. But my bearing was bottoming out on the bottom of the hole, and I couldn't make the chamfer, so I took the bearing off, which is fine. You can run the bit that way, but you have to account for the fact that the diameter of the bearing is not there anymore. Otherwise, you're going to get a really big chamfer. So that's what I got. It's okay. It's just a flesh wound. I'll just have to stare at it in shame every time I use the fence. Moving on. The top of the fence with the T-track is going to get screwed to the sub fence from the backside just using screws, and the sliding wings are attached with those T-bolts that I just mentioned. Then I can cut my T-track to match the width of the fence, screw it into place, and hey, I think we're done. Oh, actually, we're not done yet. I forgot to talk about dust collection. Option number one, if you already have an old dust port laying around like I have here, you can grab a small piece of 1/4 inch MDF or plywood, drill a 2-inch hole in the middle, and then attach that into place like this, and then you can add your flange onto that. Or, if you're starting from scratch and you don't have anything, you can buy one of these dust ports. They sell them on Amazon. The only thing that you need to do is not put these two center supports in place. This is going to become your center support. You can screw it right into place there, and it's going to serve the same purpose, and it will work on this jig. Well, I think this turned out not too far off from the original. It's just more compact, less overbuilt, and less looking like Frank. Rest in peace, Frank. We had a good run. One of the biggest hurdles anyone can face in their workshop is the shop itself. A cluttered, disorganized shop is a constant force working against your productivity. But in this video, I'm taking my shop organization to the next level. I've got a ton of tips for how to deal with hard-to-store tools, getting down into those drawers and cleaning up that clutter, as well as taking advantage of one basic rule of organization. Well, the shop isn't going to organize itself. Let's get into it. If there's one part of any workspace that can get out of hand in a hurry, it's drawers. There's no feeling like opening a drawer only to be attacked by an avalanche of chaos. But it doesn't have to be this way. Drawer organizers come in a lot of different formats, from the ubiquitous plastic silverware tray all the way to the fancier bamboo models that let your guests know you're better than them every time you host a dinner party. And while I think these options are not great for the workshop, I do think the idea can be translated fairly easily. Behold, the marvel of organization for those who like their drawers as clean and tidy as a freshly made bed. And although this setup has a lot in common with its kitchen cousins, this is completely customized to fit this space and what I want to put in these drawers. And this type of setup is surprisingly easy to execute. I mean, after all, these are just thin strips cut up and assembled together, and we can handle that. The first thing I need to do is survey the drawer for size and then have a look at everything I want to keep in there. I want to make sure I account for the dimensions and quantities of the different items. Then I want to loosely arrange some of the items inside of the drawer, or in this case, a mock-up that I drew on my assembly table, in a way that makes sense to me and that makes the best use of the space. To start, I need to cut some thin strips of plywood. I'm using 1/2 inch for this drawer. You could probably get away with a 1/4 inch if that's what you had. Cutting these strips is pretty easy. You could make these cuts on a bandsaw, but I find you get a much smoother finish if you use a table saw. But either way, I get to use one of my favorite tools, the thin rip jig. This little guy slides in your miter slot and locks into place, and then I can adjust it to cut a consistent width of strip on the outside of the saw blade. All I have to do is make the cut, readjust my fence until it makes contact with the jig again, and then make my next cut. All right, safety timeout. The reason why you want to cut on the outside of the blade and use a jig like this instead of cutting between the blade and the fence, it's just much harder to control really thin pieces, even if you have one of the fancy yellow push blocks. Because this sits in front of the blade on the outside, there's no pinching that's going to happen from making that cut. Once I was cutting a bunch of strips for cutting boards against the fence, and a piece fired back so violently that it went almost clean through the back wall of my shop. So, for the cost of a $25 jig, I'm going to make sure that doesn't happen again. Okay, back to work. To cut the grooves in these pieces, I set up my table saw with a dado stack. You could do this with a regular saw blade with a flat grind tooth, but I wanted to be able to make these cuts in one pass and move on, so it's dado stack for me. I dialed in the dado stack to match the exact width of the piece of plywood that I'm using so that you get a nice snug fit like this. I make the grooves nice and deep, about 2/3 of the way or so through the plywood. That way these dividers aren't going to fall out of the grooves. And everything has such a nice snug fit that when I'm assembling this inside the drawer, I'm not using any glue, screws, brad nails, nothing. It's just a friction fit. Nice. This type of organization works really well for drawers with large items, long and skinny items like pencils or rulers, but what if your drawers are filled with lots of tiny things? For me, one of the biggest things to avoid in a shop is disorganized fasteners. If you're not careful, you're going to spend a lot of time digging through a pile, searching for the exact right bolt, like you're on the saddest treasure hunt ever. So if you need to store fasteners, my all-time favorite find are these little 8-ounce plastic deli containers, and they're pretty cheap to buy in bulk. And I really like them because they're flat and stackable, so you can really pack out a drawer with a lot of fasteners. Obviously, they're clear, which is nice, so you can see what's inside there and know how many you have left. And if you need to get super specific about what's in there, it's real easy just to throw a label right on the top. And I find that this size container works like 99% of the time for the number of fasteners that I have. And it's just really nice to be able to select the fastener you need, take it with you to your project, and then bring that container right back to its home when you're done. But in this drawer, I keep all of my bits and drivers and things, and I don't want to use the deli containers because I don't want these locked away. I want to be able to see what I want and then grab one and go. So instead, I like to use these open containers. They come in different sizes so that I can store larger items, or they have these really small drawers to keep all of my driver bits organized. These come in a set of 42 for like $20, which I think is a pretty killer deal for organization, and they come in multiple colors, so if orange is not your jam, no problem. And they have these little connectors so you can put all these together so everything's not all loosey-goosey in here. These give me the ability to lay out the drawer in lots of different formats, and just like my homemade dividers, it's very visual and grab and go. Okay, the last tip I have for maximizing drawer storage is the use of sliding trays, and this is great if you have nice deep drawers where you can keep a layer of tools on the bottom and then another layer on top like this. The first thing you need to do is determine how much clearance you need for the items on the bottom so that the tray slides without bumping into things. Then just glue or tack a couple of strips to each side of the drawer to match that clearance. Finally, just build out some small trays that fit the width of the drawer like this. To make these trays, I just used a 1/4-inch piece of plywood for the bottom and some small strips to go around the edge. You know, taking care of my shop is important now more than ever because it's where I make my living. Recently, I went through a big life change, leaving my 20-year corporate career to run my own business. And while that's a very positive change, it does come with its share of mental and emotional challenges that talking through with a therapist could help. There's a lot of stress, anxiety, and burnout that come along with the dream of being your own boss. And heading those things off before they cause real harm is important to me. So in my default out-of-the-box state, I prefer my workspaces to be tidy and visually clutter-free. I don't really like seeing tools sitting or hanging off of every surface no matter where I turn. Do you ever try to solve a problem in your head while other people are carrying on conversations all around you and their words and your thoughts are competing for your brain's attention? For me, it's like that, but with my eyes. That's why I like things in drawers or behind closed doors, which is why I build a lot of cabinets in my shop. The fewer things that mentally get between me and my creativity, the better. But I was recently watching a video by Adam Savage where he was talking about first order retrievability, and the basic concept is that as a worker in your space, you want the tools that you absolutely use the most organized in a way that they are easy to find and close at hand. And I think I've done a pretty good job with the organizing and keeping tools close to where I use them, but sometimes I struggle with the easy to find part. It comes with the territory when you like things to be out of sight. Labeling things does help me, but it doesn't do much good if I rearrange things and don't change the labels. Over time, I've realized that there's got to be a balance, a happy middle ground between cluttered and completely hidden. And one of the ways I've changed my approach is with this drill charging station. On the one hand, it does exactly what it says it does. It charges my drill batteries, but it does a lot more than that. I keep all my drills and drivers hanging right here, ready to grab and go, and it's also pretty easy to tell when one is missing. And yes, all you people heading down to the comments right now, I know I've got a lot of drills and nobody needs that many drills. What can I say? I like drills. Those were missing. I also set up the rest of this station in the same grab-and-go style of organization. I've got my most used sandpaper here, and I have my most commonly used hand tools here and here. And I keep all my common fasteners up here. I've got a collection of construction screws, I've got a whole bunch of pocket screws, and I even have an assortment of dominoes when I need to grab some of those. These bins are really large, and you can fit a ton of fasteners inside each one of them, and they're clear so you can see exactly how many you have left, and you'll know if you need to go get more or not. And they come with labels that will go on these little thumb tabs on top, but because I keep my bins up high,
I found it better to just use a label maker and label what goes in here right on the front. This station puts a lot of tools in one place that are easy to grab and use, but still fit neatly into cubbies, which my brain and eyes seem to find acceptable. I do need to take it one step further and get that sandpaper out of the boxes and into some slots, but that's a project for another day. The next compromise I made was to create kind of the same thing, but for non-power tools. I had a lot of unused space under these cabinets, so I wanted to leverage that space by creating more grab-and-go storage. And it's pretty eclectic, as you can see, lots of random things here, but that's really the point of this type of organization. You're organizing it by frequency of use and not by the type of tool like you might have in the rest of your shop. And this is where customization is key. You may ask, well, what kind of tools should go on something like this? And I can't really answer that for you because it has to be dictated by the way you work and the tools that you use the most. It would be nice for me to just be able to tell you exactly what to do, but in this case, I'd be taking away an opportunity for you to think through how your process works and how to solve these problems yourself. All I think I can do for sure is agree with Adam that this is an iterative process. You try something, see what works and what doesn't, and then try again until you get to a place where you really have a hard time justifying making a change to your setup, which I'm absolutely sure I'll do again. Sometimes you'll run into situations where you have tools that just don't fit well inside of drawers and you need to come up with a custom solution. Take saw blades. You could just throw your blades on top of one another in a drawer like some kind of psychopath, but there are at least two reasons why. Ow! It's like an angry beaver den in there. Yeah, like I was saying, as you're busy getting mangled looking 7 deep for the right saw blade, you can also damage the carbide on the teeth. That stuff's really strong and good at cutting through woods, but not at standing up to other carbide teeth. You could do your best to try to alternate the teeth so that they don't touch one another, but that's really only going to work with something like this 20-tooth ripping blade. Try that with an 80-tooth trim blade. My solution was to create this slide-out blade organizer. This hanger was super easy to make. It's just 2 pieces of plywood connected by drawer slides and some 5/8" dowels to hold the blades. Now I can store my blades vertically so the teeth aren't grinding on one another like kids at a high school dance. And I can organize them by type of blade so that I spend less time digging through the pile looking for the type of blade that I need. It's very low profile and I can still use the rest of this drawer to store other stuff. Okay, this one is so super niche and random, but I absolutely love it because it just proves that you can maximize any and all storage space inside your shop. So if you have a 3D printer, you can make these little trays that slide right into the rail on the side of your saw stop. Now, they might work on other saws as well. I can only confirm that they work on a saw stop. And normally you would have this little plastic plug that goes on the end, but you can chuck that. We're going to be using that anymore. When you print out your tray, you can just slide it right into the side here. And now you have this tiny little cache of the most commonly used things at your saw. I've got a pair of glasses in here, safety glasses. I've got a pencil, a little ruler, and a tape measure, and I am good to go. Another one of my favorite just random storage solutions are these fast cap track racks, which are designed to hold your Tracksaw guide rails. Mine are Festool, but they'll work with any of the major brand Tracksaw guide rails. And these just screw onto things like your garage door, but it doesn't have to be a garage door. You can add them to the wall of your shop as well. These guide rails are made of aluminum and pretty expensive, so taking care of them is really smart, and that's what these track racks are, very simple and very smart. And the last type of custom storage solution I want to talk about has to do with managing hoses and power cords, and I think one of the best inventions are these retractable reels. I have one here for my air compressor hose, and it's just bolted to the wall right next to my compressor. It's really nice because it holds a whopping 50 feet of hose inside that reel, and could you imagine just having 50 feet of hose sitting in a pile on the floor? And I have a similar setup in my garage for a heavy-duty power cord. I attached it up and out of the way on the ceiling, but I can reach any part of my garage, into my workshop, and even all the way into the yard if I need power out there.
Bonus tip.
The last solution that I want to show you for drawers takes it all the way to 11 for organization, and that's using Kaizen foam to organize your tools. If you're not familiar with Kaizen foam, it comes in big sheets and a couple different thicknesses, and if you look closely, it's got a bunch of different layers. In theory, you're supposed to be able to pull these layers away using just your fingers, and I say in theory because half the time it works great, and the other half the time it looks dirty, ragged, and you end up pulling through to different layers, just not super clean looking.
But the idea is this stuff is supposed to be used kind of like the inverse of a shadow board. To use this stuff, you're supposed to lay your tool onto the foam and then trace around it so that you can cut that shape out. And this foam cuts amazingly well. You can use a utility knife or a thin razor like this one that's going to allow you to cut that shape into the foam and then use your fingers to pull out the different layers in the middle, and now your tool has its own tool-shaped home. Normally, I would say this is an order of magnitude more than you need to go for everyday shop storage. It would get really expensive and time-consuming to cut out spots for every tool in every drawer. But there is one circumstance where I found this to be immensely valuable, and that's when I was building my portable workbench. So this workbench has a drawer on each end, and I wanted to be able to carry a set of my most used tools along with the bench wherever I went, and you can't just have stuff rattling around in those drawers every time you carry the workbench. This foam allowed me to pack out the drawers with all the tools I wanted, and I was even able to double stack some of them so that nothing can rattle around or get damaged in transport. And I even found these little foam test tube carriers that work perfectly for 20mm bench dogs. It'd be super easy to lose those little suckers, and they're not cheap. And you also don't want to damage these and put dents and dings in them because they are used for accuracy and cutting. So I think this was a pretty big find. And if you're like me and you want to mix your love of organization with your love of cool tech, then you need to try this out. This is the Shaper Trace. Check out what it can do. I can take any tool, for example this chisel, and trace an outline on a piece of paper using a black marker. When I'm done, I can set my outline inside the Shaper Trace and use the app on my smartphone to take a picture of my drawing from just about any angle. And magically, I now have a digital representation that's perfectly to scale, and I can save this off as a vector file that can be loaded into any CAD software. I can arrange those vectors any way I like inside my CAD software and create tool paths for my CNC. Now, instead of using a razor to cut this out by hand, I can just make the robot do it for me. A little two-sided tape keeps the foam in place on the bed of the CNC, and a special foam cutting bit from Bits and Bits chucked up into the spindle, and I'm ready to go. The CNC can fly through this foam because there's not much resistance, and it can create a really clean pocket with a nice flat bottom. Oh, now I got a nice little bed for this chisel, and this process is completely customizable to fit any drawer space. Okay, that's it. Go forth and organize.